All right, so in the last video we introduced what it meant for something to be a relation, what it does, and basically, again, you can think of any of those matching tests you've ever done in any class ever. Uh, you were actually defining a relation. That's one way to think of it, as a mapping, matching from one group to another, where you can relate or match as many objects from one to the other as the relation allows you to. And then we talk about the domain, the range. Domain being the input that goes into your relation, and range being the output that goes into the relation. Now, if we were sitting in class right now, I would show you a bottle of water. Actually, originally would have been a bottle of soda, but and on that bottle of soda is a barcode. So I want to talk about a relation now from the point of view of a supermarket as an example of a relation, uh, one that occurs in everyday life because we all go to the store. Okay. And in the supermarket, pretty much every item that you buy now is a barcode. And what happens at that supermarket is that barcode gets looked up by the computer and it spits out a price. It spits out a price. It spits out a price. Okay, so given a barcode, it spits out a price. So the domain here in this particular problem at the supermarket would be equal to the set of barcodes for items the market sells. Right? So only items the market actually sells will be a part of the uh, domain. Right? If the market doesn't sell it, it's not going to locate it. So if you took your textbook in and scanned the barcode off of the textbook for a class at the supermarket, it's not going to know what that means. Right? It's not set up to read that. Or, if you took, a graphing calculator that you bought at Walmart and brought the box into the supermarket and scanned it, it's probably not going to read it unless that supermarket happens to sell that item. Right? So only the things that the market sells are going to be a part of the domain. Okay. And in this case, the range, well, once it scans a barcode, it's going to spit out a price. So the range here would be the set of prices for the store charges for items. And so you'll have every different price that the supermarket charges for something would be a part of the range. Now that range is not every possible price. When's the last time you bought something in the market that cost $10,000? Okay. But there are going to be a lot of prices, and there are going to be many barcodes that compare to the same price. Think if you buy a 20-ounce bottle of Pepsi, you could buy a 20-ounce bottle of Diet Pepsi, or a 20-ounce bottle of caffeine-free Pepsi, or a 20-ounce bottle of whatever. Right? There's a whole bunch of different things that you could buy there. So it could happen at the market that you could bring in a barcode that the market doesn't contribute, in which case the market function scanner would spit out an error. Right? It wouldn't give you a result. And of course, there are many prices at the market that you may not ever hit. Okay. But there's one thing we definitely do not want to have happen at the supermarket. And that is if we took our barcode here, and this was just a barcode off of a bottle of soda, 12000017174. So if we scan in that barcode for a 20-ounce bottle of soda, one thing we would not like to have happen at our market is this. Is scan the bottle of soda, and the first bottle of soda I scan comes up $1.99. Scan an identical bottle of soda, and this one comes up on the register as $2.99. And the next time maybe it's $2.58, and so on and so on. Okay, we would not like this to happen. Right? We want a consistent price when I buy this bottle of soda. Right? We want a consistent price when I buy this bottle of soda. Right? We don't want it to spit out a different price. But a relation itself allows for this to happen. Right? We don't want this to happen though with our supermarket. Right? It's okay that a bunch of things cost $1.99. That's fine. But this one single barcode, this 20-ounce Diet Pepsi, it shouldn't come out as $1.99 the first time I scan it, and then $2.99 the next time. Now we're not talking about like coupons. Like the other day, I bought there. Sometimes you buy one thing and you get one at a discount or something like that. That's different. We're just talking about the basic price of the item. Right? That shouldn't change. That shouldn't change in our supermarket. Right? That's not allowed. Right? That's not allowed. Right? We don't want that to happen in our supermarket. The price of the item should be well defined. But a relation doesn't stop this from happening. And so that's when we come up with a definition that is more restrictive than just the basic relation definition. Our more restrictive definitions say when we're dealing with this situation, we want to not have this happen, right? So we need something further that's more restrictive than just a relation. And so that object is actually what's called a function. A function is a relation where each object in A is related to at most one object in B. Okay, a function is a relation, so it has all those other qualities. It has a domain and has a range. It takes stuff from one set and relates it to other stuff in another set. But it follows another rule, and its other rule is at most one. Let's digest what at most one it says. You might think, why don't we just say exactly one? Well, then every barcode that gets scanned would have to go to a price. And in an average supermarket, that probably works. But there could be an item in that supermarket that kind of got left there and they thought they weren't selling it anymore, and it's still back on some shelf somewhere, and you bring it up, and someone has to, like, what's the price of that? Oh, shoot, that's not in their computer anymore. Uh, that doesn't happen very often now. It used to be something that would happen more often in the past, but a lot of inventories for stores and stuff are computer generated now. So that's why we don't do exactly one, right? Because we allow for that possibility that something in this set may not be related to anything. And that's okay. That's okay. Remember, poor Dana, right? Poor Dana up here wasn't taller than anybody. And that's okay. That's okay for that to happen, right? But a function is a relation where each object in A gets related to at most one in B. So each barcode is going to spit out at most one price. Or it's going to say, hey, uh, I don't recognize that barcode for your television because I don't sell televisions. I'm a supermarket, right? Right. Or it's going to spit out an error, right? But at most, you're going to get one price. This can't happen if it has to be related to at most one. So that's the idea for these relations.